No, thank you. Hey, you guys ready? Awesome. Well, thanks for having me out here. I've never been to Cleveland before. Yeah, especially after this crowd. I'm never coming back. But so the robotics team, especially Zyla, welcome me out here. So thank you. And I'm here to share with you guys the last 5 years of my journey after graduating. And I'm going to try to teach you what I think I wish I would have known beforehand, because it would have saved me a lot of mistakes and time. And time is money, so it would have saved me a lot of money. That would have been nice. Instead, I'm poor, so all of my clothing fits in the bag outside. But I'm fulfilled, so. Anyways, the talk is about innovation apathy. I'd be interested to hear from the guy on his laptop in the back. What's your name? Oh, behind him.
Hi, I'm Rob.
Hi, Rob.
Innovating, that's why I'm on my laptop.
Excellent. What's your definition of innovation?
I don't know, let's hear yours. Back to your talk.
Okay. Does anybody else want to answer for Rob? Anybody? Innovation? There's a lot of different definitions out there. It's one of those buzzwords that means nothing. So my definition of innovation, which I got from the MIT Venture Mentoring Service, is it's when invention is commercialized. So invention's great, but if you don't commercialize it, no innovation. Doesn't matter. Nobody cares. It dies in obscurity, and that sucks. But if you just commercialize something, then you're not bringing anything new to the table. You're just better at selling. So to me, innovation is the combination of those two. And that is kind of a recurring story, and it's really important that, so I'm the sales guy. I'm trained as a mechanical engineer at MIT, and my partner, Blake Sessions, is the inventor. So I kind of want to open up with, imagine for a second that you and someone else of the opposite sex you guys are the last people on Earth, and it's empty. Could you rebuild society? Would anybody here feel confident enough to say, yes, I believe we could rebuild? Nobody, right? The interesting thing is, if you ask young people this, they say yes. The younger you get, the more they say yes. But if I then said, I took the same question, I said, hey, we're on Mars now, or the moon. Could we rebuild society on Mars? Does anybody here believe that we're going to build a new society on Mars in our lifetime? That guy, he's the only one. You're the man. What's your name? Thank you, Adam. So this guy also had a pipe dream, and he did it, so I can too. So the first and most important thing I can tell you is gather believers, because everyone else is going to try to stop you, but the only way you're going to survive is if other people believe in you and they share a belief and they're going after that with you. So the people that are with me, we came primarily from MIT, and then Kyle's the only guy from RISD. We've worked at Apple, the Media Lab, Tesla, the Gordon Engineering Leadership Program, Levant Power, Duro, and Vecna. And I originally met Blake Sessions through my fraternity. It was actually through the Rush program. I was trying to get him to join because I was skateboarding down the main hallway on campus, and the professors are like shaking their fingers at me. And Blake was also on his skateboard going the opposite direction, and we kind of did this like, hey dude. It was an immediate bromance. We've been partners ever since. No, not like that. But so Blake and I were like, okay, let's go hang out, and we started just a nice casual friendship. He didn't join the fraternity because it wasn't a good fit for him, but we still took classes together. We did projects together. And the thing that starts to matter here is, where do you live? Who do you live with? What do you do with your free time? You know, what hobbies, what kind of group hobbies are you doing? And then the last one is really what kind of like broader communities or like networks are you joining, whether that's in work or some kind of extracurricular, right? So like the Robotics Club is a really good thing. You know, your future co-founder or I don't know exactly what, they're in this group. These are the people you're going to call on for the rest of your life. So Blake and I kind of had that moment at the end of our college career where we were graduating, and we had just won the capstone project for mechanical engineering. There's 16 people on the team, $5,000, 3 months. Everybody competes, and it's a blood sport, and we won. I did the leading of the team, like the management bullshit, and Blake did the technical lead, and he did the mechanism design. So then we were like, okay, we should work together in the future after we graduate at some point if the opportunity arises. But I never thought anything of it. Tomas sat next to Blake at graduation, and they shook hands because they have SESS and SEPP, and they're like, oh, that's cool. But what really brought Tomas into the relationship was I throw dinner parties, and I invite the smartest people I know that don't know each other to these dinner parties, and then I ask them, who is the smartest person you know that I need to know? And my friend Tyler, who I met through the Gordon Engineering Leadership Program, says, you got to know Tomas. So I met Tomas, and we're hanging out in his living room. He actually hosted a dinner party the second time. And I'm talking about catapult pants. And he's like, what's that? And imagine a mechanical device that starts at your boots and ends at your belt, and it gives you the sensation of swinging, like a swing set would. So there's that force on your bottom. And imagine you could like fly in a way, you jump around really high. So he really liked that idea, and we were trying to do that. And we had gotten about $400,000 from some interesting investor characters that wanted us to do this. I know, right? Seriously, believers, they're great. I'll get to him later. Bill Warner is the man. So Tomas really liked this, and 2 weeks later he joined us because you're only young once, so why not? Kyle was from RISD, and I was just giving first and helping this other guy who had started an appliance company, and there's not that many people building hardware companies, and then within those hardware companies there's not that many people that can raise money to keep going. So he was struggling, this guy named Matt, who's a mutual friend with Kyle and I, and he got introduced to me through somebody from the Techstars program and another guy from the Gordon Engineering Leadership Program. So two people separately introduced this guy to me and said, can you help him? So I helped him out. He got off the ground, and I asked him to reciprocate by introducing me to a designer. I was looking for somebody who could take what we were doing and help other people understand it. So everything that you look at and see that has to do with Rise Robotics, like the colors or the layout or the slides, Kyle does that. He also does the product enclosure design, so he works in Blender and does STL files and 3D printing and blah, blah, blah. But the most recent guy is Mike, and he's actually not really a believer. And this is really important. So he believes enough to entertain us, but he's what I call a defensive pessimist, and he balances everything out, because if we're all just like, oh my God, we believe, optimism, then we just float away and pop. So Mike kind of keeps our boots on the ground, and as we try to fly away, he reels us back in. He's like, that'll never work. And then we argue, and eventually we kind of meet this common ground where Mike's right, but I'm right. But then sometimes Mike's right and I'm wrong, and I'm like, dang it, Mike. Because he's always like wagging his finger at me for shooting from the hip and stuff. So you have to have like the team is, that's all that matters. So the way you raise money is you build an awesome team that has experience in the industry, that really cares about the mission, and is going to stop at nothing to get it done. So these guys, we've ran out of money and been completely unpaid for 6 months. And we moved in together and stole all the free food from campus when no one was looking. We signed up for vultures at MIT, and we'd get these emails from the events when there was too much food. Blake lived in my living room, and we used the kitchen as our workshop, and we used Tomas's basement as the fabrication facility where we built up these machines and bought stuff and got things for free. And this is what's important. Has anyone ever seen this? One guy again. Jeez. Great. Well, I'm going to play it real quick because I think it's important. This guy at Sivers, he taught me this on the YouTubes.
If you've learned a lot about leadership and making a movement, then let's watch a movement happen start to finish in under 3 minutes and dissect some lessons. First, of course, a leader needs the guts to stand alone and look ridiculous. But what he's doing is so simple, it's almost instructional. This is key.
So this is actually not me. That guy that's dancing is Blake. But he's always teaching me how things work.
Publicly shows everyone else how to follow.
I'm that guy.
Notice how the leader embraces him as an equal. So it's not about the leader anymore. It's about them, plural. Notice how he's
I'm going to skip ahead. This gets pretty out of control.
guts to be your first. You stand.
So we'll go to here.
They won't
Right, we're a minute and 30 seconds in. There's like, what, 24 people?
the in crowd if they hurry.
This is what we call getting in on the ground floor. It's when you've actually started to get some ground effect lift and things are taking off and the internet dies and then you crash. But then you take off again and before you know it, there's this mad dash to get inside. Edward Land from Polaroid talked about it. He called pressure outside the window. It's where like you throw this party inside and you're like, hey, everyone come to the party, but no one wants to come until a certain point, and then everyone wants to come and a line builds outside. And then you go over and you open the window and let people in. Whether it's money or employees or customers, at some point the demand outstrips the supply.
Leadership is over-glorified. Yes, it starts.
So leadership is over-glorified. What's important is to be a good follower. The best leader supports first. They follow first. That's a great way to end that.
There's no
So I had supported Blake in the Capstone project pretty aggressively. There's actually this very controversial decision that he made to outsource all of our fabrication for our final product and not make any of it ourselves. And that's like heresy in the mechanical engineering community, at my school anyways, because we do things ourselves. And so we just paid Proto Labs like $1,800 and it showed up a couple days later. It was their first cut service. And the other teams were laughing at us because we spent a bunch of money. We spent like a third of our budget on this one outsourced fabrication. But we won, so that's all that matters. And what I'm trying to get at here is that Blake really appreciated that support. So when he graduated and he was thinking, should I get a PhD? Should I go work at Apple? Or ... he called me to see what I thought about ... He had been working in the biomech lab building clutches for ankles and knees, prosthetics and orthotics. And he had been kind of fantasizing, but also applying his skills to producing real things for his fantasy. And his fantasy is exosuits. It's let's make ourselves physically stronger. Let's build wearable machines that amplify our strength, stamina, speed, and it's totally possible. We actually already have these. There are tens of thousands of them being made and delivered in Japan as we sit here, and they're in the military, but they're not everywhere, and it's because of some fundamental problems. So Blake calls me up and he's like, what should I do? And I say, you are too smart and too young not to do what you think matters. So take a little bit of time, take a little bit of risk, and go chase it. But he didn't know how to do that, so I hung up on him, and I called up Bill Warner. And I said, hey, Bill, there's this really bright guy that needs your help. And I had met Bill through my hobby group, the Gordon Engineering Leadership Program, and Bill was an advisor to the program, and he had all these wacky ideas about how to grow it. And when I started the program with him, it was 10, and now it's 250. So he had some really good ideas there. He also started Avid, which makes, they pioneered digital video editing, and he won Oscars, technical Oscars. So Bill meets with Blake, and same day he writes a $25,000 check. He hand-holds him through the incorporation process and all the nuts and bolts of getting a business up and running, and Blake is off to the races, and he just starts making things. So he does this for about 3 months, and then I join full-time because there's way too many little problems that are weighing down Blake's productivity. So again, I'm building the company around Blake, right? Because stage 1, we need to get to an invention. And once that invention is good enough, then stage 2 comes in, and then we build the company around me, because then I'm going to commercialize it. And that's where we are now, after a lot longer than I thought. So this is kind of what his original vision was. He wanted to have a power system that would pull from a battery and deliver mechanical motion. You need to have some joints. What's not shown here are the springs that are like tendons that are in series between the joints in them. So joint, tendon, muscle, joint. So Blake identified the technical challenges, and he was wrong like 4 times at least. And what I mean by that is he thought it was springs and joints and clutches and harnesses and actuators. And we didn't get to the actuator one until 2.5 years in. But finally we got there, and we realized that actuators are actually about half of the problem in personal robotics becoming mainstream. And we read this really interesting paper by these guys at this company called Robotics that went under because they could not commercialize. And they talked about this ancient thing called the windlass by the Chinese. It was used for wells and sailboats. So it's a device that you turn the crank and it creates a linear contraction or elongation. It just does a rotary to linear transform and gear reduction simultaneously based on that step size. But there's also some really high forces in that winch pulling down, so you have to have really big bearings. And there's also necessary friction on the drum. But Blake thought that he could get rid of all those things and also make it much more compact. So he created this thing that you see moving around called the cyclone drive. The patent issued, and it's inherently, fundamentally, a better way to do high speed to high force transformation. For thought experiment, this could be made out of ice and it still works. It actually works better. So you don't actually need friction between the drum that's driving and the belt. Compared to a ball screw, for example, just the ball screw itself, so don't count the motor and don't count anything after the ball screw. If you just look at the transmission itself, this is 200 times more power dense. But in addition to technical challenges, we also knew there were going to be market challenges. So most people laugh when we say we're going to make exosuits for everyone, and that is the right response, because that is a new market that doesn't exist, and it's a suicide mission. And there's a lot of dead bodies there. So in addition to technical challenges, if you then layer market challenges on top of that, that's way too much risk, and you're done. So what we decided to do instead is we have this methodology called FAST products, and it stands for fun, affordable, simple technology. Henry Ford learned this the hard way. He put 2 businesses out of business, despite being backed by the most powerful, wealthy people around him. Before he started the Detroit Automobile Company, he worked at, anybody know where he worked before? He worked at Edison's lab alongside Tesla. He was the chief engineer in New York City, putting in DC power circuits all across Manhattan. He moved to Detroit. He starts a car company. He wants to bring cars to the masses. Out of the gate, he realizes they're going to be really, really expensive, so they're not affordable. And he's also selling them as a utility device, kind of like the Segway. This is going to be the next generation of mobility, the human transporter. And everybody laughed, and it went out of business. So finally, after a lot of pain and suffering, and this is the keyword that you want to search for to verify this, if you don't believe my story, is called the sweepstakes car. It was made in 1901. It was 6 years before the Model T, right? And before the Model T, there's the S, and it goes all the way back to A. But before A, there's the sweepstakes. So what he realized was that you need to capture people's attention. And if it's not fun, nobody cares. So a modern-day version of this is Tesla. The very first car they make is a sports car because it's really fun and it gets headlines. And the better version of the Segway is the Swegway. Have you guys seen these? It's a Segway without the handle. It's a little device. You lean around on it. There's also these like one-wheel things. So now there's this explosion of fun segways, and it's catching on. Same thing with drones, by the way. They existed for a little while. Nothing was really going anywhere. And then you get the Parrot at Brookstone, and off we go, toys, right? And then you guys have probably built drones for fun, right? Has anyone here built a drone? A dozen? Half a dozen, right? And it's because it's fun. I mean, like, you might like rationalize to yourself that you're gonna do something useful, like pick up the mail. I don't know. Anyway, so he does this, he wins the race, he gets propelled to fame, the spectators are so enthralled. It also proved that the product was simple because it was robust and it could stand up to the rigors of racing. And clearly there was a technology breakthrough. You know, he's making better motors, Ford Motors. Same thing, Tesla Motors. So we applied the same principle and we realized that components alone are not going to work. We need to be radically independent. We need to apply it to a case study. We need to show everybody that it is in fact better with a really simple, fun, and affordable technology. So what we did is we made a better type of air compressor for contractors. We made the robotic air compressor. So in the same way that Roomba made the robotic vacuum, and people bought that because they wanted to see their cat drive around. Seriously? I mean, like, why do people buy Roombas? Cat videos. It's 15% of the vacuum cleaner market. So at some point, you know, you're no longer a robotic vacuum, you're just the vacuum. So I believe, and the rest of my team believes, that the robotic air compressor will be just the air compressor, because the mechanism inside of it is more efficient at converting the energy that's coming into it from either the circuit, which has a limit on the breaker, or a battery, which has a limit based on size and cost. We're going to get more power out. So it's the benefit of that feature is for the contractor, it's faster to fill. They don't wait, right? So bang, 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 they just keep shooting. And they never have to wait for the air compressor to fill back up again. It's also lighter weight by half. So they can carry it around easily. And it's inherently quieter because it's more efficient. So this really simple air compressor trick, 4 years of struggling to make any money at all, we just finished this a week ago. I sent it to a guy in my network who was the former executive merchandising president at Home Depot. He sent it to an OEM that loved it. They flew us out to meet with them. And now we're negotiating for distribution on a really massive scale. And I couldn't get people to buy Cyclones to save my life. We make a really dead simple air compressor that just takes a Cyclone, adds a piston to it and a tank, you throw in some regulators and an enclosure, and wham, it's done. So I'm going to review, and then I'd like to take questions to see what you guys want to know. But my takeaways are, please, for the love of God, innovate. Otherwise, humanity's kind of doomed. We're never going to get to Mars. We're never going to have complete abundance and the elimination of poverty. Really important things are never going to happen if we don't create better technologies. In order to do this, you really need to remove your limiting beliefs because you're actually holding yourself back. If you're blaming other people, then you're just surrendering control to them because you've removed yourself from the equation and now you have no impact on the outcome, so it's your fault. But the good news is if you admit that it's your fault, then you now have control so you can do something about it. But you have to first remove those limiting beliefs, and you have to kind of put yourself out there a little bit and dream. But the only way you're going to survive if you're dreaming is if you have other people sharing the dream and that one dude who doesn't believe any of you and occasionally drags you back down to the ground. And then you're just going to have to be really, really persistent and also get believers that are older than you, who have money and experience on all sides, right? The downstream distribution, the downstream retail, the upstream manufacturing, the finance, right? There's lots of moving parts in this puzzle, and you're not going to make it alone. So thanks for having me, and I'd really love to answer any questions.
Hey, can you explain how the cyclone works?
Yes. Yeah, objection handling is a really important part of sales. So you should know your objections and you should handle them. And this is the number one objection. There you go. Yeah, the objection is, how does that work? But that only happens if you first explain what it is. Otherwise, people are really confused. Let's try this again. So I'll just talk over this. I had it all preloaded. Let's do this. It's no longer pending, it's issued. I need to update that. That's a really important piece in the negotiation process with these suppliers downstream. Pending is not really that valuable. It's kind of like a placeholder. This sucks. Come on. Cool. So we've got a motor on the left. We have a drum down the middle. We have a continuous belt with a termination on it. That's where the white turns to orange. And then there's pulleys. So fundamentally what's happening is we are expanding the coil's diameter while shrinking the legs, and shrinking the coil's diameter while expanding those legs. So if you imagine a pencil rolling on a string, if it's a solid, if it's a cylinder with no change in radius, then you don't get any contraction. But if you taper that drum and now you rotate it, for a constant rotation, you're going to get a different real on rate than a real off rate, and that constant step size gives you a constant contraction according to the input rotation. So there's your gear reduction. The steeper you go or the shallower you go, the different the reduction. The shallow tapers are actually really high reductions, which is kind of interesting in the sense that it's easier for the cyclone to do a really big gear reduction than it is for it to do a very small one. So now we're going to do the rearrangement dance, where we remove the unwanted torques. So this is not that yet, but you'll see in a second there is now like a three-fold or three-flute or three-start symmetry. This is the fundamental principle of the windlass. So the output is between the two pulleys, and the motor is actually floating. So you don't have to mount the motor. There's no. I'll give you guys a sneak peek into what's coming. Actually, the coupler now we're doing an integrated motor rotor. So imagine inside that mechanical rotor that is now like your electrical rotor, and the stator's on the inside like an outrunner. So then your connection between the motor and the rotor is magnetic instead of mechanical. So your losses go down, noise, heat. We still haven't done the threefold. It's coming though, I promise. The belt is really important. That's the tensile element. So we're treating the materials the way they wanted to be treated. The tensile elements are in pure tension. The compressive elements are in pure compression. But the tensile element has to bend over a drum in what's called cyclical bending over sheave. That's a real big pain in the butt. We used to do twisted and braided ropes and belts like you see in really large things like mining or elevators or gondolas and chairlifts or winches on the marine boats, but that doesn't work. The better thing to do, because we want to do industrial applications and things that last for a really long time for consumers, is like what you see in the front of a car on a serpentine belt. So the interesting mechanism there is that if you have, you guys know what tension shedding is? Does anyone know what tension shedding is? So if you have a twisted rope that goes over a pulley, as it goes over the pulley, it's going to untwist and retwist in order to preserve the compressive and tensile forces that are different radially from the pulley. So if you do a flat belt instead, where you don't have stacked tensile elements, then they're all the same radius, and you don't get any internal abrasion. Does that make sense? Yeah? It took a long time for us to even understand it. We were kind of just like throwing spaghetti at the wall and seeing what stuck. Oh, hey, no, stop. Something that upsets me, actually, that is in context with that, what just popped up there, is look at the difference between how Japan receives robots and how America receives robots, and then connect that back to the brainwashing that occurs in the media from a very young age. So, for example, Terminator. Seriously? Like, that is most people's idea of robots. They're going to take our jobs and they're going to kill us all. And then you go to Japan, and you get things like Astro Boy. Seriously. And the Japanese love robots. So they have this company called, SoftBank and Foxconn put $250 million into a robot called Pepper. Does anybody know who Pepper is?
Yes.
Cool. So Pepper's going to take your job. No, but in Japan, Pepper is the coolest thing. So you want to go shop at that store. So it's like, I don't know, right? Like, the media is important. So even if you're not into engineering, science fiction is the predictor and creator of science faction, right? So if you can plant the idea in people's heads, then they'll make it real. Questions? Maybe I'll take a couple more, like 5 more or so. Last call.
Would you like an access to?
What's that?
When do I get
2018 for $10,000. We're actually going to do a Kickstarter soon to see how much demand there is. And just for a comparison, the cheapest exosuit out there right now is about $65,000. And the key asterisk there, and this is actually about going back to that technical problem and the market problem. So exosuits right now have found a market that has a very low technical functional requirement. So if you think for a second about a rehabilitated or a paralyzed person who currently uses sticks, that's state of the art, sticks with handles, or wheelchairs, which really haven't changed since bicycle technology in 1920. It's ridiculous. It really is ridiculous. If you look at the functional requirements for the specific task is gait training, physical therapy, rehabilitation. It's not something that they wear all the time. They wear it occasionally for like 30 minutes to an hour, attended to by a physical trainer, and this competes with a much bigger, larger, more people necessary to operate physical therapy device. And then all it has to do, since they're pairing the exoskeleton with sticks with handles, they put all the weight on the sticks with handles, and it's just going to be stimulating the muscles by swinging them during the swing phase. So it's not even doing like real work in a squat, for example. It's doing swing, lock, fall, swing, lock, fall. So the technical requirements are really low for physical therapy exoskeletons. And that's the only spot that the technology that exists today can go. And simultaneously, they're in a lot of pain. So they currently spend about $1.7 million on drugs and physical therapy and really expensive wheelchairs, which I don't understand why they're so expensive. Oh, it's the FDA. It's all that regulation they have to comply with. So an interesting thing you can do is you can make a sporting exoskeleton, and then if it's good enough, people will buy it and use it for rehabilitation. And that's the way around the FDA. You make it, right? Because the cool thing in Chicago, actually, there's a precedent set in law where toys like skateboards and trampolines and snowboards are no-duh dangerous. So if you buy that and use it and kill yourself, it's your fault. But if you get a medical device, So then it adds a lot of cost because then you have to reduce risk. So the markets are not ready, and that's why we're doing air compressors. Yeah.
Okay, so air compressors now,
More power tools next.
Exactly, okay. That's
Yeah, there's a gap. Yeah. So more power tools. For example, single operator loading and unloading from trucks. Right. So you're a contractor. You've got 3 80-pound packs of shingles. You need to get them out of the truck. You could do that, or you could have like a gurney type wheelbarrow thing that unloads the truck and then you drag it on wheels. So one of the nice things about getting a partner in this space, this guy from Home Depot, he also spent 2 years at Home Depot in their innovation department. So he actually figured out with his team what all the big problems were that no one could solve. And then they tried to solve them. And some of them they couldn't solve, and there's still these outstanding problems that nobody can solve. So when I showed him our air compressor and the cyclone drive, he was like, holy crap, I think you could do these other 10 things. Here's the functional requirements. So then we actually built a really cool MATLAB model simulation where we put in functional requirements, hit go, and it tells you exactly the size and the materials of the cyclone necessary to make that happen if it is possible. So yeah, we don't know what's next, but it will be in the same channel, because once you're in a channel with a customer, you've already invested all this upfront cost, and it'd be really dumb to go to another channel and invest more upfront costs when you could just continue to sell into the same channel, especially once you've built trust. People like what you made in the air compressor category, so they're going to buy your sawhorses that change height while loaded.
How would the actuators actually mount to the exoskeleton and actuate the exoskeleton?
Currently top secret, but that is a really great question. This is a very gestural, artistic rendering, but we do have answers to that. So some things we keep inside. Most of the time we try to share everything because we want other people to make it better and copy us, as long as they pay us for things that we own. So anything that is a derivative of compact windlass is Rise Robotics. You can send your royalty checks to me. Yeah, I'll send you my contact info. Yeah, Sila.
So in the beginning of the Cyclone Explained video, there shows the gear efficiency and the cyclone efficiency. Can you explain why
Yeah.
there's that drop off and why this is better than gears?
Yeah, so that's a little bit of a convolution. So there's this other, in addition to the efficiencies that we get from the mechanisms, contact mechanics or tribology. So instead of using Hertzian contact with concentrated forces with really high pressures, we use distributed forces over large areas. That's the first thing I talked about. But what we kind of show in that upfront video, which we don't talk about that much, is what we call profiling, and it's kind of like continuous variable transmission, where as a function of the stroke, we can do different reductions. So, we could, for example, do a forward and a reverse, and the forward could be a low speed, and the reverse could be a high speed. So then with the same motor, you have 2 gears, and if that's an hourglass shape, where one side is lopsided longer than the other, the center of that hourglass is neutral, and then either direction is a different gear ratio. Or you could do like torque normalization, right? So whereas with a servo at a shoulder, you're going to get a different amount of torque as you go out. So then the motor is optimally used at the farthest point and underused at the closest point. We can actually make it so it's optimally used throughout the entire range of motion, so it'll draw a constant current and output a constant torque. And the gear reduction takes care of the changing torque at the joint. Probably bored a couple people, but I hope someone cared about that. Cool. How many people are mechanical engineers? About half you guys. Computer science. Nice. Cool. Mechanical engineering is not done. This is not the end of history. New things can happen. So. Okay, I think that's it. Thanks, guys. Uh, 30 by 12 by 15? Currently it's 20 pounds. But it's moving around right now. It'll do 120 psi at 2.8 SCFM, which is enough to power all nail guns and multiple of the smaller and medium-sized ones. It'll also do high velocity, low pressure paint guns and really limited use of other power tools. But it won't do things like grinding or impact wrenches that just continuously dump air. So.
Thank you so much for coming out. Really appreciate it. Here you go.
Awesome.
Woo.